let me just share my screen. Okay, so for the system exam Kirchhoff's. So in your Kirchhoff's quiz, so most of you got at least 80 and above. So your highest is 95 out of 110. Okay. So you guys have actually got everything aside from this part. All right. So the last question is the P total loss in the resistors. Okay. So I don't know what happened, but most of you have only answered 272. Okay. So you guys have only calculated the loss on the resistors RA and then the resistors RB. You guys didn't included the resistor on this one, the first one, 0.15. Because if you're going to add this one, the total loss, okay, will be 512, not 272. Well, there is only one. There is only one who got this one correctly, okay, which is Miss Gunayam. So this is her solution. All right. So as you guys can see for the P total, so he only got the a total current, okay, which is the 40, and then the total resistance, which is 0.32. Okay, so you've got the parallel connection of this one, and then added this one in series connection, and then you will get 0.32 in total. Okay, so yeah, you can do this one, and you will get 512 watts, or you can. Where is the other solutions? Or you can do this one also. Okay, the power loss in RA. Can you guys see this one? Okay, the power loss in RA and then the power loss in RB plus the power loss on the 0.15 ohms. Okay, so in total you will get 512 watts. But since as you guys can see, he only, I mean she, I don't know, maybe he or she, I don't know whose solution is this one. But yeah, he only added the power loss in RA and RB. Okay, 128 plus 144 is equal to 272. So that is why most of you is incorrect with the last question on the number 2. All right. And then the rest, I guess, super easy already, especially the question number 3. All right, so let me just show to you guys the step-by-step solution of question 1, 2, and 3 so that we are clear in everything. So I'll just use the solutions of Miss Gunayan. All right, so for the number 1, we have this circuit. So we have this loop, okay? So clockwise and then counterclockwise. So for the node A, okay, so we have IA plus IB is equal to IL. So again, how did we get this IA plus IB? So let's say that this is your node A, okay? It's just that there is no label. Let me just get. Oops. All right, so to those who still cannot get on how to, do some loopings, KCL loopings, KVL loopings. So it is very important for you to have your assume flow of current. Like for example, in here, he or she have assumed that the flow of current is coming from here and then right here. So what I always do, it's always coming from the positive. Okay, so this one is actually correct. So we have this flow of current. And on the other side, on the other side, we also have this flow of current wherein it's coming from the positive. So that is why we have this flow of current, okay, counterclockwise. So once you're done in assuming your flow of currents, then you can now start putting some polarities or signage. So as always, if it's across the resistance, then this one is a voltage drop, okay? So if we have positive in here, so you should have positive, negative in here. So it's going out on the negative sign. All right. So this resistance will deduct some of the voltages of this voltage source. So the same with the RL. So positive, negative. And then right here, we have positive, negative. So again, we have a voltage drop in here. So we have negative, positive. So again, my style or my technique is it's the sign that I always get or follow as my final sign is the outer, okay, where it leaves the component. So in here, it leaves at positive. This one, it leaves at negative. And then right here, it will also leave at negative. So again, in Kirchhoff's law, so always start with KCL. So let's just say that this is your node A, KCL at node A. So in here, it's very easy. So just follow the sign. So positive, sorry, the one that I'm doing is a KVL. So again, in KCL, whatever is the one that is entering to our node will be signed as positive. Whatever is the one that is leaving our node, okay, let's say this is our node A, will be assigned as negative. So that is why we have here IA. Okay, so IA is going in with our node A minus, okay, minus IL, or you can do this one first, positive IB, because we also have a current here that is flowing inside or flowing in with our node A. So either of those two will be fine. And then, as you guys can see, there is one current that is leaving this node, which is the current IL. So I will be having negative IL is equal to 0. All right, and then just arrange this one so you can have IL is equal to IA plus IB. All right, so yeah, that's it. You can now use this one as your reference to solve for the IL, IE, and IB. Okay, so how do you do that one? So in here, just perform KVL. So KVL at loop 1. So let's just say that this is your loop 1 and then this is your loop 2. Okay, so we already have the signs, so you can follow those signs already. So 24 or positive 24. So again, KVL is Kirchhoff's voltage law, so we're only getting the voltages. And right here, we have currents and we have resistance. So again, going back from our Ohm's law, V is equal to I times R. So as long as you have the current and then the resistance, then you can have the voltage value. So in here, we have the current and we have the resistance. So minus, so why minus? Because it's it's a voltage drop and it's leaving on the negative side. So minus 0.4 times IA. Okay, and then minus right here 0.8. Okay, so 0.8 is the value of your RL, and then 0.4 is the value of your RA. 0.8 times IL. And then going back to our voltage source. So once you're done in every part of the components that it will pass through, then just equate that one into 0. So this is already your equation 1. Right? And for the KVL at loop 2, so were you guys able to follow? Is there anyone here who wasn't able to get the number 1? Yes, all of you got this one, since this one is super easy. So this is your quiz on Kirchhoff's law, so number 1. So are you guys still listening?
Yes, sir.
Yes, sir.
Because if all of you who are here have got the correct answer on question number 1, then I will not show the solution anymore. Then I'll just go to the parts where you guys have got an incorrect answer. Because the others who didn't attend to our meeting is maybe not interested in knowing where they've got incorrect or got a mistake. Anyway, so let's just finish this one and then we'll move on to the question number 2. So KVL at loop 2. So in here we have positive 26, okay, minus 0.4. There is a mouse, a mini mouse passing through. Anyway, so minus 0.4 times IB. Okay, so the current in here is already IB or labeled as a current B minus 0.8 times IL is equal to 0. So in here, this is already your equation number 2. So from there, we can already perform simultaneous equation. Okay, so you can eliminate either IL or IB. Yeah, IL or just IL. Okay, so in here you can eliminate IL and then have a new equation with, no, it's not possible because we have two different components. We have IA in here and then IB in here. So simultaneous equation is not possible. So in here, you can equate the equation number 1, okay, to get the IA or IB. So one of the solutions of your classmate separated or get the IA, okay? There you go. So i-zoom ko na lang. Okay, so from equation, where's this came from? From equation number 1, okay, right here. Maganda yata pag. All right, so from here, from equation number 1, right here. So you've transformed this one into this one. Okay, so you've only separated the IA. And then once you have the IA in here, then you can now substitute the value of IA on our equation number 2. Okay, so 0.8 times IA, which is this 124 minus 0.8 IB divided by 1.2 plus 1.2 times IB. So with this equation, you will be able to solve one variable already, which is IB. Okay, so just simplify this one. Okay, simplify until you will get oops, until you will get this one. Okay, this kind of equation. 31.2 minus 19.2 divided by 0.8 is equal to IB. All right. And then just simplify this one or just solve this one using your calculator, you will get 15 amps. Okay, and then from here, things now are easier since you already have the value of IB. So you can now solve for the value of IA. Okay, just substitute this IB on our equation 1, then you will now be able to solve for the IA. Then you will get 10 amps. And once you already have the IA and IB, then you can now use the KCL equation. So IA plus IB is equal to IL. Okay, so just add those two, IA plus IB. 10 plus 15 is equal to 25. All right. And what is the third question? What is this VIL? VL. The voltage load across RL. So in here, oops, divided times. All right, so in here, since you already have the voltage across your RL or IL, then just perform Ohm's law. V is equal to I times R. And the resistance across this RL is 0.8. So 25 times 0.8 is equal to 20 volts. Okay. And then for the, what is the last question? And power across this RL. So in here you can perform, oops, you can perform this one. P is equal to I squared times R. So the current across that resistance is 25, and then the resistance across that node or path is 0.8. So 25 squared times 0.8 will give you 500. Right? So those are the correct answers for the number 1. All right. And for the number 2, so this one is also super easy. So just have 2 loops, okay? Just perform 2 loops. So first loop on the outer and then second loop on the inner. So for the outer, let me just get this one. There you go. Okay. So again, just perform 2 loops. So the outer is your first loop, and then the inner is your second loop. So for the loop 1, we have this one. So positive 122. You already transferred. Anyway, so you will get 122 minus 0.15 times I. Okay, since the current that is flowing in here is the total current. And minus outer is 0.25 times. So in here, we have 2 currents. So we have IA and IB. So we'll just only get the IB for the loop 1. So 0.25 times IB. And then going back to the loop. Okay. Sorry, I missed something. That is why we have 110 here. So in here, we have another voltage. Okay. So this is a voltage of the node B. Okay, let's just say that this is your node A. This is your node B. Okay, which is 110. So as you guys can see, we have here a polarity of positive and negative. So what I always get is the outer part. So positive right here, negative right here, and then negative right here. Okay, and then positive, negative for the resistance. Then just perform that one. Okay, and then you will have the same equation with this one. Okay, so just transfer everything. So positive 122 is equal to 0.15, etc., etc. And then for the loop 2, so just consider the inside. Okay, so we have here negative 108. And if you're going to transfer the negative on the other side, you will have this equation. 122 is equal to 0.15, I plus 0.5, IA plus 108 volts. So once you already have those 2 loops, then you can now perform simultaneous equation. Okay. So in here, he have eliminated the I sub B. So in that case, he will be able to solve for the I sub A. All right. And since you already have the I sub A, then you can now substitute this I sub A on either. Oops, I sub A. What is the missing value here? Total current. It doesn't have KCL. KCL at if this is your I total is equal to IA plus IB. All right, so from here, you can substitute this IA on our loop number 1. Okay, I actually, no. It should be on loop number 2, sorry, because that is the one that has a variable of IA right here. Okay, so once you already have substituted the value of I sub A in here, then you can now solve for the I total. Okay, so once you have the I total and then the I sub A, then you can now solve for the I sub B. Okay, so that is another way for you to be able to get the I sub B. Okay, so in here, you already have the IA, IB, and I total. So what's next? What is the question on number 2? Okay, IA and IB. Then you can now get the total loss or power total loss on the circuit. So in here, the question is open circuit. Right here. So calculate for the IA, IB, I total. So we have already calculated that one. So the only two remaining questions unanswered is the power across generator and then the total power loss on all of our resistors. So again, I have already mentioned this one a while ago, that in calculating for the P total or total power loss, okay, is you must have the total current and then the total resistance. In that case, you will know or you will have or you'll be able to get the total power loss on that circuit. Okay, or you can get the individual power loss. So like right here, we have the power loss in RA, power loss in RB, okay, and then the power loss in 0.15. Okay, right here, 0.15 resistance, and then just add everything, and then you will have, where is that one? You will have 512 watts. Okay, and then for the right here, power of the generator. So I don't know what happened with Miss Gunayon, but this is her one mistake. Okay, so supposedly she got a perfect score, but then he included or he used this formula V squared divided by R, which is correct for the getting the total power. However, we don't have a resistance or internal resistance for the uh, generator. Okay, so I don't know where this R came from right here. Came from the total resistance. But this one is incorrect. Okay, because the correct one is just by using the P is equal to IV. Okay, as long as you know the total current and then the total voltage, then you'll be able to get the power across this generator. So the correct answer for that one is 4,880. All right. Not, it is not 46,500. So this one is quite big, right? And then for the last one, so just perform two loops. So one here and then another one right here. And then you'll be able to have these equations and then just perform simultaneous equation. Then you will get or just eliminate either IL or IB to get the one variable. And in here, he chose to eliminate the IB. So in here, he was able to get, she was able to get IL. So once you have the IL, then you can now substitute this one on either the loop 1 or loop 2 for you to be able to obtain the I sub B or I sub A. Okay, so in here, the next one that he've solved is the I sub A. And then once you already have the, I sub B. This one is I sub B. Okay, and then from the KCL, IA is equal to IB plus IL. And that's how you've got the value of I sub B. So 24 plus 12 is equal to 36 times. All right, so yeah.